So we're verifying trig identities. To verify whether an identity is true, verification is just like a check. And you've done checks for a long time, even since junior high. And we stuff goes flying. You need like 4 desks. Her eraser's beside you as well. She's lost everything. So, when we check, what we do is we fill into left side. Stop singing. Okay. Complete song show at this point. Okay. So the left side you fill in, the right side you fill in the same variable. You move nothing from left to right. You move nothing from right to left. And you just see if left side equals right side. You've done it for forever. Even when you did solving in junior high, you would find out what the x equaled, and then you plug it in and see if left side equals right side. Exactly. All right. So it says here, when verifying, never cross over the equal sign, as it is an electric fence and you will be zapped and hurt quite badly, I might add. This is no joke. Do not cross over it. So here they want us to verify theta equals 60 degrees. So we're going to plug 60 in for every theta and see if it works. A verification just proves that for that answer it works or does not work, correct? If we want to do a proof, and we want to prove it works for everything, we can't plug in any values. We have to keep the thetas and show that left side equals right side. But when it's verification, you're literally just verifying for only that value we know it's true. Could it be true for more? Sure. But for that one value it is. So we want to verify 60 degrees for this formula here. Our first step is to rewrite that exact same formula, but instead of thetas, you're going to put in 60s. So we're going to go secant of 60 degrees equals tan of 60 degrees over sine of 60 degrees. I don't know why I put the tan in the bracket. So we did secant 60, tan 60, sine 60. We just did that. We practiced that in the review part of the thing, right? So we just need to find out what those values are and fill them in. So our very first step, paying attention, because people will get this wrong. Our very first step is to not change secant to 1 over cos. Our very first step in verifying is take value, plug in for theta. If you do anything else, you're proving, and you don't even know that you're going to start doing it that way. You are. When it says verify, your very first step has to be take degree, take radian, and fill it in for theta. Okay? Don't change anything, just put them in. All right. Now we need to find out what the heck secant 60 is. So off to the side, I'm going to write secant 60. Secant goes with what? Cos. So go find cos. Tell me what cos of 60 is. It's 1/2. So what's secant of 60? 2 over 1. So it's 2. Then we need tan of 60. Tan of 60 is the same as sine of 60 over cos of 60. How do I remember if it's sine over cos or cos over sine? I don't remember it. I just go to my what? Formula sheet. Right up here. The 2 top ones, the very 2 top formulas tell me how to find tan and cotan off my unit circle. Very top 2. So what's sine of 60? Root 3 over 2?
Oh, sine 60.
Yeah. Root 3 over 2. And then we'd be stacking divided by 1/2. But do I ever stack fractions?
No, sir.
No, I immediately say, nope, don't do that. Write it sideways. So I get 1/2. So I get root 3 over 2 times 2 over 1, which is just root 3. Remember I told you that all 60-degree tans are either positive or negative root 3s? All 30-degree tans are all what? Positive or negative, do you remember? 60-degree tans are root 3s.
Okay.
30-degree tans are what? Negative root 3 over 3. So if I have a choice, I'm picking 60s. They're easy. You forget, it doesn't matter. You can find it out. And then we need our last one, which is sine of 60, which is y at 60, which we've already said is root 3 over 2. So now I have all my values. secant of 60. So I fill in my 60s, then I go secant of 60. Okay, that's 2 equals, what's tan of 60? Root 3 divided by sine of 60. So do I stack, this could be a fraction on the bottom. Do I ever stack fractions? No. I'm going to write it side by side. Sine of 60 is root 3 over 2. Now, can I multiply the root 3 over 2 over? Am I allowed to do stuff like that when it's verifying? Can I move stuff from the left to the right, stuff from the right to the left? No. It's as if there's an electric fence here. There's an electric fence along here. You can't cross over it. Okay, do you see that bright yellow line? We're not allowed to cross over it. We have now 2. We have to show that it actually works. So we can go 2 equals root 3. And what do I do with the fraction? With division? Multiply and flip. What happens with my root 3's? They cancel. And now people will say, they equal. Do they equal currently? Could some person, like my grade 2 child, walk up and be like, yeah, they look the same. Do they look the same currently? No. It has to be like a grade 2 kid that walks up and says, 2 equals 2. And now they'd be like, yes, this is good. The one before that would be like, what is this garbage? That's what they would say. Okay? And then we have to always do this. We have to go left side equals right side. If you don't go LS equals R, it's the only short form you're allowed in math. LS equals RS. You don't even have to write left side equals right side. It's the only short form you might as well take advantage. So there's 2 ways we can show verification to get full marks. This is one. Your first step is to set this equal to this, fill in, right, immediately for theta. Get your answers, put equal signs the whole way along. Never drop off the left, never drop off the right. You see that? That's one way we can do it. The other way you can do it to get full marks is you can go like this. You can go left side. You can go LS, I guess. You don't have to go left side. You can go LS. You can go RS. And then you just fill it in. So you go secant 60. Secant 60 is 2. And then you can go tan of 60 over sine of 60. And you don't need an equal sign when this is happening. You're just working your sides down. So you'd go root 3 over 2. Oops, root 3. Divided by root 3 over 2, which is root 3, times 2 over root 3. And you'd have to have equal signs running down these sides, though, showing that these are equal. These cancel, and I get 2. And now, do they look the same? Yeah, so at the end, I can go LS equals RS.
Like, do the correct one, though, like the 2 column, do you have to do that, or can you just stick to the...
So I said you have 2 options. Both will get you full marks. You can choose whichever one you want. But you have to do them correctly.
Okay.
So the errors happen on both of them for different reasons. This is one. So for this one, the error happens in, people will see there's a 2, and then they drop the 2 off and just bring it back at the end. That you'll lose marks, because that's not verifying it, right? To verify, you need a left and a right each time. So if you're doing it this one, Sean, just make sure that you go this equals this, this equals this, this equals this, this equals this. Like you have to always have something on the left and always something on the right. If you choose to do the table, you can go secant 60 and break it down with equal signs running down. You can do tan and sine of 60, break it down until they match, and then go left side equals right side. So then you would only have to write the 2 once instead of every single step. Do you know what I mean? Doesn't matter which one you choose. It just matters that you do it correctly. Okay. I want you guys to try pi over 6. Now, when you put in pi over 6, which you're going to, your first step is going to be putting it in. Cotan of pi over 6 equals cos of pi over 6, sine of pi over 6. You have to write it like this. You cannot write 30 degrees. Because am I verifying 30 degrees? No, I'm verifying pi over 6. We agree? But if I know that's 30 degrees, can I just go and like do the work in my head knowing it's 30 degrees? Sure. Doesn't matter. Show your work off to the side, see if you get the answer. So we have cotan of pi over 6, which we can do off to the side. Cotan of pi over 6. We're not going to show this work you're not going to go cos of pi over 6 tan of pi, or cos of pi over 6 with sine of pi over 6. You're not going to do that in here. You're going to do all your work off to the side. Okay? So cotan of pi over 6 is cos of pi over 6 divided by sine of pi over 6, which is root 3 over 2, divided by a half, which is root 3 over 2, times 2 over 1, which is just root 3. So I can go root 3 equals, and then this is technically just that, again, right? This one's really silly. So it'll be root 3 over 2 divided by a half. But do you see if I'm using this instead of the table, I have to have my left side carry down. Every single time I have to have a number on it. My right side make the sign number. Number. So I have root 3 equals root 3 over 2 times 2 over 1. These cancel. And I get root 3 equals root 3. And I get LS equals RS. Do not forget the LS equals RS or you will lose marks. That is actually important. If you did the table, you can go LS, you can go RS. You would still go cotan of pi over 6 on the left side, and you would go cos pi over 6 divided by sine of pi over 6. And then you would show your work. So you'd go equals root 3. And here you go equals root 3 over 2 divided by a half equals root 3 over 2 times 2 over 1 equals root 3. And then you can say LS equals RS. Why can you say that? Because LS is root 3, RS is root 3, LS equals RS. Right? I do not care which method you use as long as you don't make it, say it wrong or do it wrong. Wrong steps. Okay. Then I said to try the next one. So we have cotan squared x. Remember I told you cotan squared x is the same as saying cotan x all squared. It's like you have two cotans. Okay? So I'm going to go cotan squared pi over 3 plus 1 equals cosecant squared pi over 3. So off to the side I'm going to find cotan of pi over 3. Cotan of pi over 3 is cos of pi over 3 divided by sine of pi over 3. Cos of pi over 3 is root 3 over 2. It's a lie. Cos of pi over 3 is a half. Divided by sine of pi over 3, which is root 3 over 2. So we get a half times 2 over root 3, which is 1 over root 3, which rationalizes to root 3 over 3. So I can fill into cotan pi over 3. I can fill in root 3 over 3. But it's what? It's squared. Because this just means I have cotan pi over 3 twice. Plus 1 equals, now I have to find cosecant of pi over 3. Cosecant goes with what? Sine. And what's sine pi over 3? Sine pi over 3 on your unit circle is? Root 3 over 2. So cosecant is? 2 over root 3. It just flips, right? You can flip answers, you can't flip angles. So you get 2 root 3 over 3. So on this side I'm going to get 2 root 3 over 3, but squared, because I have 2 of them. If you're someone who's never coming up with the answers off the unit circle when I'm saying, what's cos of pi over 3, what's sine of pi over 3, you need to have your unit circle out and be following along and find those values because you think you might know how to find them, but you sometimes don't. And we find out at the test, and it's a scary place. It's not a team test. Okay. So we have root 3 squared is 3. And then 3 squared is 9 plus 1 equals, now we have to square everything. The 2 is squared, so it's a 4. The root 3 is squared. It's just a 3 in brackets over 3. So here I'm going to get 1/3 plus 1 equals Oops, it is, because I'm like, that's not going to be equal. Good catch. So we're going to get 12 over 9. What's 1/3 plus 1? It's 4/3, because it'd be 1/3 plus 3/3, right? Which is 4/3. And what's 12 over 9 reduced? 4/3. So now I can say LS equals RS. Then we're going to flip over. Yeah.
What if you like write out the answer like unsimplified instead of just do this 12 over 9 12 over 9 get
No, that'd be fine.
oh,
Yeah, as long as they match.
alright.
Yeah, like you could have 12 over 9 equals 4/3 and say left side equals right side. You know what I mean?
Okay.
Okay, there's this one, and this one. We're doing them tomorrow at the very beginning of class. I'm going to come around and check and see if they're done. Done.